Okay, you need to know water has a tetrahedral shape. Okay? But it becomes a bent molecular shape.
What's up, Blair? What's up, Purple?
So when you're figuring out the shape of water, you've got oxygen in the middle. Okay? And these lone pairs are not shown in the molecular shape. Okay? The lone pairs of electrons on the oxygen help define what the shape is, but the actual shape is bent. This is a bent molecular shape.
Oh, that's what hydrogen.
Ball and stick form.
That's hydrogen.
The structure of methane. Methane is CH4. A methane molecule is a tetrahedral.
And Mr. Taylor, you got a pencil I can borrow? Nah, but you give him $1 to let you borrow.
So this is a tetrahedral. A tetrahedral molecular shape. So water starts out as a tetrahedral, but when you take the lone pairs off, you actually get a bent molecular shape. Okay? All right, now, the structure, using this ball and stick concept, the structure of carbon dioxide.
Yes, but that's what I need.
You pissed me off. I told him to stop.
Can't say the word
Say
piss.
one more word.
Can't say the word piss. Cuss word. Don't say it.
Piss a cuss word. Piss is a cuss word.
As a teacher's reference, yes.
But it's not you.
So this is the unhybridized orbital notation for fluorine. It's what we learned in the last unit. Okay? These orbitals we learned in the last unit had a shape where the p orbitals are double balloons.
Hey, when is our big test on this? Today or Monday? This word.
Hope it ain't no deal. We don't take it serious.
Hey, so what did I miss yesterday?
You missed a funny article.
What y'all built? What y'all learned yesterday right there?
You missed a whole lot.
I think so.
Stop.
We didn't know what I was.
We're not going to use this.
So these are three p orbitals, and p orbitals have a double balloon shape. The double balloons, each of these double balloons are on an axis. So if this is the z-axis here, it could be the y-axis or the x-axis, it doesn't matter. But if, in this example, this is the p-axis, the z-axis, then that makes that pz, and this is pz. And if this is py, it could be px, it doesn't matter. But if we say it's py, then we're going to label it py.
Don't they have to be diagonal across from each other?
Yes, they have to be diagonal across each other. You can say that.
Alright.
And that would make this one then px. Okay? And then we also have an s orbital in that valence level that goes around that. So, this orbital here in the orbital notation is this s orbital right here. this p orbital can be any one of these 3p orbitals here. You have 2 electrons, 2 nodes, but they're the same thing. So if this p orbital is pz, then it's also the pz orbital here. 2 balloons make 1 orbital.
Wait. So is this a hybrid?
This orbital, if it's py, and it doesn't matter whether it's py or px, but let's say it is py, then it's also this py, because it's 2 parts. The orbitals have 2 parts. Doesn't really matter, because this doesn't designate whether it's px or py or pz, and the only reason we call these px, py, and pz is because we're identifying which axis they're on. Okay, so this last one then, in this case, will be px, and so that makes this one over here on the back side also px. Okay? So that's how orbital notation is related to the drawings we did. That's what they are. This is just a different way of representing orbitals in terms of being able to figure out what's going on. Okay? So here's the unhybridized set of orbitals for fluorine. So all I did was to redraw exactly the same thing I had up here. And I'm going to hybridize this to sp3. If I want to hybridize to sp3, I've got to take one s and 3 p's and make them into the same kind of orbital.
I know when you add another one on them.
We count all the electrons in the valence level, 1, 2, 3, 4, 5, 6, 7, and put all those in these orbitals one at a time and pair up where we need to. 1, 2, 3, 4, 5, 6, 7. And that's an sp3 set of hybrid orbitals. Each of these orbitals became something new over here. So this orbital has become one of these. And this orbital has become one of these.
That's a hybrid.
This is a hybrid over here. Okay? This orbital has become one of these. And this orbital has become one of these. They've all become something different by hybridizing. Now, this set of hybridized orbitals is also related to a shape. This is just an organizational scheme, a kind of inventory of electrons. The actual shape of the orbitals is something a little bit different. This is where you have 4 different balloons. So the shape of these orbitals is a single balloon. At least that's the way we think about it in high school chemistry.
Is that like the analogy version? Or not
This is,
comparison? Or whatever?
yes, we're comparing it. It's the actual shape of the orbitals.
Right, I didn't mean analogy. It tastes as water, too. It tastes like pouring water. I guess.
Okay?
Trust me. I
So this is what a set of sp3 hybrid orbitals looks like. Okay? So each of these orbitals are sp3 hybrids, just as all 3 of those are. I mean, all 4 of those are.
You got what? Ebola. Ebola. What? What is that black stuff on the eye?
So what I'm going to do here is to redraw this set of hybrid orbitals up here in orbital notation
Are you making fun of me right now? Are you the best?
So this is sp3 hybridization here. This is the way that we hybridize or show the hybridization in sp3 form for fluorine, sp3. So all of these are sp3 hybrids here. Each of these right here relate to some part of this. One of these balloons is an sp3 hybrid. So that orbital could be that one. This one could be this one. This one can be that one right there, and this last one over here could be that one.
She went to the bathroom.
The 1s, we're actually going to get to that, okay? Just so bear with me. We're going to do that next. Or not, maybe not next, but shortly, okay?
Can I go to the seniors bathroom?
As long as you have one arrow from each of these 4 boxes going to a separate balloon over here, it really doesn't matter. Okay, because they're all just sp3 hybrid orbitals. All right, so here is another drawing of our unhybridized set of orbitals.
Hey, this was y'all look yesterday.
No, we've been learning this for a while.
Oh, this the hybridized?
This is the unhybridized form.
Why do you invalidate the other one?
Hey,
Why do you invalidate the other one?
there's a chemical or a thing that you mentioned yesterday that they put inside their bodies a long time ago to preserve them.
Well, they still use it. It's called formaldehyde.
No, it's something else. Something else with it.
That's the only thing I've talked about.
Into the veins.
No, I haven't talked about that I know
My
of.
mom said it.
I haven't talked about putting anything in veins. Okay, so this is the unhybridized set of p orbitals. Okay, and the s orbital surrounds it. Okay, and this is the set of hybridized orbitals.
That's a boy.
Okay, each of these
No, I did not.
unhybridized orbitals changes and becomes one of these orbitals. The 2p orbitals that make up this one here, it could be px, py, or pz, doesn't matter. The 2 of them become one of these. So if we want to take this one, and it doesn't matter which one, but if we want to take this one and make it this hybridized orbital, then this orbital has to be part of the same thing. Okay? If we want to take this one right here and make it this hybridized orbital, then this one here has to be the same thing.
So it don't matter which one you put it to, just make sure you have both of it.
Yes, that's exactly right. And if this one is going to be this one over here on the back side, then this one over here, which is part of the same thing, has to go to the same place. Now, the s orbital, can please be quiet and listen. Please be quiet and listen. The s orbital is always also one of these hybrid orbitals. It also changes into that shape. Okay?